Okay, as we now start in section 4.4, we're going to go over some terms. One of the terms that we're going to review is a multiple. Multiple of a number is the product of a whole number and any zero, non-zero whole number. We're going to list the factors of 6, and we're going to list the multiples of 6. In our factors of 6, they are 1, 2, 3, and 6. The factors of 6 are called a finite group, which means they are a certain set. The multiples of 6, you'll notice that they keep going on and on and on. They're an infinite number. They're an infinite set. So the factors of 6 are finite. The multiples of 6 are infinite. We're going to learn how to find a common multiple. A common multiple is a multiple that is shared by 2 or more numbers. So, for example, I'm going to list the multiples of 4, and then when I feel like I've gotten to a point where I have found a common multiple, I'll stop. Again, each number, multiples, will continue to go on and on. But as I compare these two numbers, I can see that their least common multiple is 12. So in number 3, the least common multiple, which is the least of the common multiple for 4 and 6, is 12. Notice the difference. The greatest common factor of 4 and 6 is 2. You need to make sure that you understand what the difference is between a multiple and a factor is in two numbers. Now in number 4, we're going to find the LCM, which is the least common multiple of the numbers, by listing the multiples. So since I'm listing for 2, I'm just going to list them out as far as I think I need to until I find a common multiple. Now I can tell that the least common multiple of 6 and 8 is 24. Now I notice I'm finding the least common multiple for 9 and 10. I'm noticing that I'm trying to find the multiples of 10, which will help me to give me a clue that when I need to stop on the multiples of 9. Now, if you are asked to find a least common multiple of two numbers, sometimes when you list them out, there's room for error in case you forget to list one. So we're going to discuss a better way of finding the least common multiple. And as I noticed, prove my point, there is a multiple here that I left out. So as we go onto the next screen, number 5, you can find the LCM of 2 or more numbers using prime factorization. But pause the video and let you find the prime factorization for 24 and 30 and list it on number 6, for example, 24 and 30, listing their prime factorization. You can either do the factor tree or you can do the upside down division, L method. we now have the prime factorization for 24, which is 2 cubed times 3, and the prime factorization for 30, which is 2 times 3 times 5. Now, in number 6, it says you multiply the highest power of all factors that appear. So, in order to find the least common multiple, you take each factor in the prime factorization to the highest power, multiply them in order to find the least common multiple. For example, in these two numbers, I'm going to take, since I ordered them from least to greatest, I'm going to take 2 cubed. The next one will be 3. The next factor is 3. The next one is 5. When I multiply 2 cubed times 3 times 5, I get 120. The least common multiple of 24 and 30 is 120. So now we're going to try to find the least common multiple of the numbers using prime factorization. I'm going to pause the video, let you refer to the previous example, do the prime factorization, then the LCM, and we'll come back and we'll check it. Okay, note, I did the prime factorization for 36 and 72. I took each factor to the highest power, then I totaled it. Notice the way that I put them. Listed each prime factorization, then right below it put LCM. The same for 20, 22, and 55. I did the prime factorization for each one. Took each factor to the highest power, but also remember, put them in order. It helps you to keep your work organized. Now we're going to find the least common multiple of monomials. We're going to use the prime factorization of each one of these. Again, list them just like this in order from least to greatest. And each factor to the highest power. So in these two monomials, the least common multiple is 45x squared y squared. Each factor to the highest power. One of the terms that you're going to be using in this lesson is the least common denominator. It is of two or more fraction. It is the least common multiple of the denominators. Last year, a winter resort had 144,000 visitors, including 45,000 snowboarders. This year, the result had 160,000 visitors, including 56,000 snowboarders. In which year was the fraction of the snowboarders greatest? So in this word problem, we're going to determine which is greater by putting them in fraction form and simplest form. So in last year, we're going to look at last year's first. We had 45,000 snowboarders out of a total of 144,000 visitors. And this year, we had 56,000 snowboarders out of 160,000 total visitors. Now, we are going to reduce these fractions, and again, you can reduce them by dividing the numerator and the denominator by the same number. So in our last year's total, we can already divide the numerator and denominator by 1,000. When we do that, we have 45 over 144, which is a fraction reduced. Now, let's think of another factor that is in 45 as well as 144 so that we can divide the numerator and denominator by it. So we have found a common factor of these two numbers, so we're dividing the numerator and the denominator by the same number, which is equivalent to 1. So we're going to be able to reduce this fraction to 5/16. It's a friendlier number, I call it. So now we're going to simplify the next fraction, which is this year's. So we're going to divide the numerator and denominator by 8. So our reduced fraction is going to be 7/20. Now, we need to determine which is the larger, 5/16, 7 or 7/20. So we're going to do that by finding the least common denominator, or the least common multiple of 16 and 20. So in order to compare these two fractions, we try to find the least common multiple. We're not trying to reduce them anymore. We've already reduced them enough. So now, since we're trying to compare them, we need to find the least common multiple to compare them with. So 5/16, we multiply the numerator and denominator by 5, will be 25/80. Now we can compare the two fractions. 28/80 is the largest, which would be this year's, and the greater. There are two strategies in order to determine what the LCD will be, the least common denominator. You can do a prime factorization and take each factor to the highest power. Or another strategy is that I have found is you take the larger of the two denominators, which would be 20 here, and do the multiples of 20. 20 times 2 is 40, times 3 is 60, times 4 is 80. And you can use the larger of the denominators and find its multiple, see until you get one that would match the other denominator. But again, the other ways you could use prime factorization. Now, in 10 and 11, you're asked to find the least common multiple of the binomials. I'm going to pause the video and let you go back and look at your notes to determine what is the least common multiple of these two problems. Please check your work. Make sure you listed them in order from least to greatest. And you chose each factor to the highest power. Okay, I have two more. I will pause the video. You can come back and check your work on these. Okay, notice the LCM for each one, and they each have been put in order. When you're dealing with variables, put them in alphabetical order. Now we're going to use the LCD to determine which fraction is greater. Find the least common denominator for each of the fractions, compare them, and then circle the fraction that's greater. I'm going to pause the video and we'll come back and check our work. Okay, again, notice we found the least common denominator. If you found a larger one, that's fine. But sometimes it's easier to work with smaller numbers. You'll still have the same answer because their fractions are equivalent. So we found the least common denominator, compared them, and then circled the greater fraction. Okay, finally, on number 18, we're going to order these numbers from least to greatest. But what I'm noticing is they're in different formats. So I'm going to put them all in mixed numbers. So I'm going to keep 3 and 4/15 the same, but I'm going to change 33/10 to a mixed number. This is like a division problem. 33 divided by 10. 10 goes in there 3 times with 3 left over. 3 times 10 is 30, plus the 3 is 33, so you get 33/10. And our last fraction, improper fraction, is 19 over 6. 19 divided by 6. 6 goes in there 3 times with 1 left over. Now we can compare. Our least common denominator is going to be 30. So I'm going to remember to bring over my whole number and change them to equivalent fractions with a denominator of 30. Now I can determine which is the smaller of the fractions, and that would be this one, but I need to put it back in its original format. So I'm going to make the smallest fraction to be 19 over 6. My next one was going to be 3 4/15, and the final one will be 33 over 10.